sun, earth, water, and air. These natural forces provide the energy that sustains our daily lives. Our challenge is to harness the energy within these elements without causing damage to the environment. If we fail to meet this challenge, our children will inherit a world of scarred landscapes and devastating pollution. The environmental problems we face are urgent and demand solutions. Finding answers begins with the realization that all of us as individuals can make a difference. Energy conservation is an important part of the solution. Hi, I'm Jim Powell. Preserving the environment requires that we conserve our energy resources and learn to use them more wisely. It means that we practice recycling, reduce waste, drive more fuel-efficient automobiles, and design energy-efficient homes. And that's what this program is all about. How to build an energy-efficient home that will pay for itself and provide year-round comfort. The next 20 minutes, Russell Home Builders will show you how to design an environmentally friendly home that assures outstanding comfort and savings.
It's called the Energy Smart Home. It's designed to draw much of its power from a renewable and inexpensive source of energy, the sun. Consider this. Because an Energy Smart Home is so efficient, less coal is required to generate electricity for heating, cooling, and lighting.
As a result, on an annual basis, we save up to 3 tons of carbon dioxide from entering our atmosphere. If more homes could conserve energy like this, we'd be able to help reduce pollution significantly. Our environment is a national treasure. We're responsible for preserving it for ourselves and our children. Designing energy-efficient homes helps lay the groundwork for preserving what we treasure.
Energy Smart is a modern and responsible approach to building homes for the 21st century. Phillip Russell, architect of the Energy Smart Blueprint, is a 3-time winner of the coveted Grand Aurora Award for Excellence in Energy Efficiency. This award is given annually by the Southeast Builders Conference. He captured the Florida Governor's Energy Award for his Blueprint for Energy Efficiency. He also earned the prestigious United States Department of Energy's National Award for Energy Innovation. And finally, the Diamond Builder Award from Home Buyers Warranty for the achievement of excellence in construction standards and first-class customer service. This Energy Smart Home is over 2,600 square feet and has a utility bill averaging only $64 a month based upon 6.2 cents per kilowatt hour. Not only does it provide year-round comfort, but it's also an investment in the future. As energy costs rise, this home will yield thousands of dollars in savings.
Hi, I'm Phillip Russell. This is my wife Francine, my daughter Kelly, and my son Kevin. My interest in building energy-efficient homes started with the Good Sense program about 12 years ago. The program had been developed by Gulf Power in Pensacola, Florida, and was being made available to both builders and homeowners nationwide. What attracted me to the Good Sense program was that it provided easy-to-follow concrete guidelines on how to build an energy-efficient home. It covered everything from installing additional insulation to the use of heat pumps. I think one of the most important aspects of the Good Sense program was that it educated consumers as to how they could make their homes more energy efficient while using conventional building methods. As a result, consumers started demanding energy efficient design. This ultimately benefited our business. Then about 3 years ago, we took the Good Sense principles and further developed them so that we could achieve even greater levels of energy efficiency. As a result, I was able to create the blueprint for the Energy Smart Home. We discovered there were a lot of people out there who wanted to buy this type of home, not only for increased savings and comfort, but also because they were designed to be friendly to the environment. I think Americans want to move toward energy independence. That's one of the reasons why I feel that in the coming decade, building homes that conserve energy will be an important issue.
The goal of our program is to help you become more informed about what it takes to build a home that conserves energy and provides year-round comfort. We'll do this by watching Phillip Russell construct a house using his award-winning Energy Smart design. In fact, the house I'm standing in front of is the one you'll see built from the ground up. Let's go inside and take a look around. This home is tightly built. and well insulated from top to bottom. The heating and cooling system is powered by a geothermal heat pump. This uses far less electricity and is more efficient than almost any other conventional heating and cooling system on the market. A programmable thermostat by Honeywell helps minimize fuel costs while maximizing comfort. The solar water heating provides hot water at practically no cost. Features like an electronic air cleaner and mechanical ventilation help ensure a healthy home environment. They circulate plenty of fresh, clean air. Almost everything in this home is designed for energy efficiency, including special windows and doors that reduce heat loss in the winter and heat gain in the summer. Even the appliances, plumbing fixtures, and lighting provide energy savings. All of these features work together to yield a remarkably low utility bill, averaging about $64 a month, based on 6.2 cents per kilowatt hour. I'd like to stress that our purpose here is not to give you a lengthy step-by-step guide on how to build a house. Instead, in an easy-to-understand way, we're going to show you how an energy smart home is designed to provide outstanding comfort and savings. It's also important to remember that the blueprint for an energy smart home is one that can be successfully implemented in just about any climate. With that in mind, let's get started. Selecting the right building site is one of the first decisions you'll have to make in planning for an energy-efficient home. It's important that the site allows you to orient the wall with the most window area southward.
This way, you'll benefit from passive solar heating in the winter. During the summer, it'll be easier to keep the house cooler and take advantage of natural ventilation from summer breezes. This graphic shows how a southward orientation works. During the winter, the sun travels at a lower arc. Therefore, it can provide direct light into south side windows. That's passive solar heating. It's free and friendly to the environment. During the summer, south side windows receive less direct light because the sun travels at a higher arc. Properly sized overhangs provide shade and help reduce heat gain. There's something else to consider when you plan a site. Try to preserve all the trees and foliage that you can. They provide natural shade in the summer and act as a barrier to cold winter wind.
All of the design features we've just seen have a purpose. They help maximize comfort and reduce heating and cooling costs. It's a hallmark of an energy smart home. Before we begin construction, let me explain a thermal envelope. The energy smart home has a carefully designed thermal envelope surrounding the living space. Think of a thermal envelope as the home's protective shell, composed of various layers. The layers make up the wall system, ceilings, floors, windows, and doors. Their purpose is to provide insulation. They also block unwanted moisture and prevent air leakage. A well-insulated thermal envelope controls the flow of heat in and out of a house. This means in the winter, it retains heat for warmth. In the summer, it keeps heat out so you can stay cooler. If a thermal envelope doesn't control the flow of heat, it's like throwing money out the window. This is very important to understand when it comes to energy efficiency. To help me explain it a little more in depth, I'd like you to meet Mr. Heat.
Hi, I'm a bundle of energy, but they call me Mr. Heat. Gotta go now, it's getting too hot in here for me. Bye.
Now, Mr. Heat is always trying to find a way to pass from a warm area to a cold area.
Ooh, I gotta get out of this heat and into that air-conditioned house where it's nice and cool.
Remember, Mr. Heat is crafty and always looking to get in or out of a thermal envelope. He can do it in 3 ways.
Yeah.
Conduction, traveling through solids like walls, floors, and windows. Convection is when he moves through the air and can slip in or out of cracks and openings.
It's a tight fit, but I can make it.
And finally, there's radiation.
Whee! Hey, Banzai! I made it. So long.
That's how Mr. Heat travels in waves. When the summer sun strikes the roof, it gives him the chance to radiate directly into your home. One last comment before we begin construction. To maximize efficiency and comfort, the thermal envelope of an energy smart home is made of insulating materials that have a high R value. R value is simply a material's ability to resist the flow of heat in and out of your home. We've given you an overview of why a thermal envelope is so important. Now we're going to show you how it works as an energy-saving system that includes walls, floors, ceilings, windows, and doors. Let's get started with the foundation.
The floor of this home is slab on grade, meaning that the foundation is laid right on the ground. A sheet of 1-inch styrofoam brand insulation made by Dow is placed on the surface of the filled dirt after it is leveled to prevent unwanted heat gain or heat loss through the floors. It's strong, durable, and has superior water resistance. The next layer is polyethylene vapor barrier. This is essential in blocking out damaging moisture that can rot wood or ruin insulation. Vapor barrier also helps keep uncomfortable humidity from getting into your living space. Next, a layer of steel wire mesh is applied. Finally, the concrete floor is poured. The combination of vapor barrier and Dow styrofoam brand insulation not only retards moisture, but also does a good job of keeping floors warmer in the winter. Now that the house is being framed, work has already begun on the wall system. Let's take a look.
One of the features of an energy smart home is that exterior 2x6 wall construction is used instead of 2x4. One of the advantages of a 2x6 wall system is that it allows for more fiberglass bat insulation to be installed. It also allows installation of headers above windows and doors. 2x6 walls are a good way to conserve energy and increase efficiency. In fact, it can give up to 91% more insulation than standard 2x4 walls. Let's take a closer look at how a wall is built to form an energy-saving system. The sheathing is placed against the exterior 2x6 wall construction. Next is Tyvek house wrap, a DuPont product that acts as a windbreaker to help stop drafts. It covers cracks and seams where air could leak through. What makes it so valuable is that it's made of a material that blocks air infiltration, yet allows moisture to pass through so that it doesn't get trapped in the wall and cause rotting or ruin insulation. Next is new high-performance 5.5-inch R21 fiberglass bat insulation from Owens Corning. We've used this kind because compared to others, it has more insulating value per square foot. This means it can do a better job of conserving energy and can even reduce the outside noise level in the home. The next step is to apply a polyethylene vapor barrier to block out moisture. It's the same kind used for the floor system.
As this graphic illustrates, when a wall is finished, it appears in the form of layers sandwiched between the stucco exterior and the interior drywall. As a system, these walls have an R value totaling 28. This will be quite effective in keeping the house comfortable year-round and help reduce your energy bill. It's important to mention here that most interior walls in an energy-smart home are insulated. Therefore, 2x4 walls are used. Not only do they help maintain desired temperatures, but they also make the home quieter through soundproofing.
Insulating the ceiling is a fairly easy process. But an energy-smart home also uses a modified energy truss to increase the insulation in this area. As you can see here, these modified energy trusses raise the roof 3.5 inches higher than conventional trusses. The additional insulation installed in this space will reduce unwanted heat gain or heat loss. The first layer on the ceiling surface is polyethylene vapor barrier. Next is R19 fiberglass bat insulation. On top of that is Owens Corning loose fill insulation called Thermoglass. This is blown into place to equal an R40 in the ceiling. Here's another feature of an energy-smart home, Tyvek radiant barrier made by DuPont. It does a good job of reducing the heat radiating through the attic and into your living space. Tyvek's metallized surface actually reflects heat and helps keep the house cooler during hot weather. Before we move on to how windows and doors are part of the thermal envelope, let's look briefly at preventing air infiltration and leakage. As we discussed earlier, a lot of energy can be lost this way. That's why all cracks and openings must be sealed. This not only helps conserve energy, but it also helps maintain comfort. In an energy-smart home, sill seal is applied between a wall frame's lower plate and the concrete floor. This seals the narrow gap between the two and reduces heating and cooling losses.
This Dow product is made from ethafoam. It acts as a gasket and easily compresses to seal gaps. Sill seal is applied to all the exterior walls surrounding living spaces. It's a simple, cost-effective process that really pays off. An energy-smart home even seals all openings for wires and pipes. And speaking of pipes, All hot water lines are insulated, including the water heater. Without a doubt, preventing air infiltration and leakage is essential for comfort and maintaining the effectiveness of a thermal envelope. But we need to keep in mind that a certain amount of natural ventilation is also essential for comfort. That's why this Energy Smart home is designed with an attic ventilation system built into the roof. It features soffit and a ridge vent. The system works like this. As the air in the attic space becomes heated, it rises and is forced out the ridge vent. This creates a thermal siphon, which pulls in cool air through the soffit vents. This process helps keep the attic space cooler.
Windows and doors provide natural ventilation too, and they're also a part of the thermal envelope. That's why casement windows are used. With the help of this home's southward orientation, these windows are designed to catch both spring and summer breezes. Windows and doors can account for up to 40% of a home's heat loss. They're the weakest part of a thermal envelope, but their efficiency can be upgraded. That's why an Energy Smart home uses windows and doors that provide excellent insulation. For maximum efficiency and low maintenance, we're installing Andersen casement windows and patio doors. They're made with Andersen high-performance glass. As an insulator, they're effective for several reasons. To start with, the space between the two panes of low-E glass is filled with argon rather than air. Argon has significantly more insulation value, yet is harmless to the environment. The low-E glass has a special coating that helps prevent energy loss during winter or summer. Andersen windows are also carefully sealed with a weather stripping system that makes them waterproof and prevents air leakage. The wooden exterior frame is protected by the company's PermaShield system, meaning they're vinyl clad, which makes them practically maintenance free. You don't have to worry about the window frame or sash corroding. All of these features work together, cut down on heating and cooling costs.
The Andersen patio doors being installed here in the back also have the same high-performance glass as the casement windows. For added efficiency, they're made with a patented locking and weather stripping system that provides excellent weather tightness and security. In fact, these doors can withstand 50-mile-per-hour winds with 8 inches of rain without leaking a drop. The new ever-straight fiberglass entry system, you get the rich beauty of wood, the endurance of fiberglass, and the performance of a totally engineered system. The best gets better when it comes from Pease.
As we mentioned, windows and doors are the most vulnerable areas of the thermal envelope. A lot of energy can be lost through them. Using the kind of windows and doors we're shown will certainly make a home more energy efficient. With the installation of windows and doors, our thermal envelope is brought to completion. A tightly built envelope made of quality materials helps ensure that the heating and cooling system works as efficiently as possible. That brings us to our next topic, the heating and cooling system. The heating, cooling, and hot water systems of an Energy Smart home draw much of their power from the sun. At the heart of this system is the closed-loop geothermal heat pump made by water furnace. It's 3 to 5 times more efficient than a conventional heat strip system found in many homes today. An important part of the hot water system is the solar water heater that provides free hot water almost all year round. On exceptionally cloudy days, the geothermal heat pump will utilize the solar heat stored in the ground to heat the water. The geothermal heat pump is reliable, easy to operate, and uses very little electricity.
The job of a closed-loop geothermal heat pump is threefold. First, it cools the house in the summer by taking heat out of the home and releasing it into the ground. Second, it provides heating in the winter by extracting heat from the earth and transferring it into your home. Third, it works 5 times more efficiently than an electric water heater to provide plenty of hot water all year round. The basic components of a closed-loop geothermal heat pump are the pipes installed in the ground and the heat pump unit placed in the home. Water in the pipes is continuously recirculated from the ground to the heat pump inside. The water furnace heat pump can provide warmer air in the winter and take out more humidity in the summer, providing total comfort more efficiently than conventional air-type systems. In winter, the water furnace heat pump extracts heat from the water circulating through the ground. It's then transferred to the air in the duct system, which distributes it throughout the house. To cool your home in the summer, The heat pump extracts heat from the air in the house, then transfers it to the water in the closed-loop pipes. As the water is pumped through the pipes, heat is released into the earth. Since the earth is cooler, heat naturally passes into the ground. To help this system achieve maximum efficiency, the network of air ducts throughout the house are placed in a conditioned space so any leakage remains within the thermal envelope. They've been installed between the first and second floors. In many homes, the ducts are placed in the attic, where they're exposed to extreme temperatures which result in 10 to 35% less efficiency. The other part of the system that receives its energy from the sun is the solar collectors manufactured by Thermomax. On the roof, they are installing the solar collectors that will convert the sun's energy into heat and electricity. The heat produced in the evacuated tube collectors will be transferred to the water heater via an antifreeze solution. The electricity being produced by the photovoltaic panel will power the circulating pump, which transfers the energy from the solar collector to the tank. On sunny days, the Thermomax system will produce enough hot water during one day's operation to supply a family with enough hot water for use during the evening and into the next day. During periods of cloudy weather, the water furnace heat pump will use solar energy stored in the ground to heat the water. Harnessing the sun's energy like this results in enormous savings.
The Energy Smart Home is designed to be a healthy, comfortable place to live. Recent EPA studies have shown that indoor air can be far more contaminated and harmful than outside air. A home can trap smoke, pollen, chemical pollutants, and even radon, a colorless, odorless gas that's been linked to cancer. Even viruses and coals can be recycled. That's why an Energy Smart Home is carefully designed to create a healthy home environment. All of the features you're about to see work together as a system to provide everything from clean air to precise year-round temperature control. This energy-efficient system provides year-round comfort and can yield significant savings. Let's take a look at mechanical ventilation, a feature that's being used more and more in homes and office buildings. Since this house is tightly constructed, very little air will pass in and out of living spaces. That's why mechanical ventilation is essential to maintaining a healthy, comfortable home environment. The purpose of this heat recovery ventilator made by Air Exchange is to bring in fresh outside air while exhausting stale indoor air. This new supply of air is then circulated throughout the house without creating uncomfortable drafts. Indoor air pollutants like smoke, pollen, bacteria odors, and even radon are removed and replaced with fresh filtered air. This particular model also has a unique feature called a heat wheel that warms, cools, and dehumidifies incoming air according to seasonal needs. This feature conserves energy and provides additional comfort. In winter, the heat wheel absorbs heat from air being exhausted, then gives it to fresh incoming air. This process allows cold air to be warmed before entering the living space. During the summer, the process is reversed. The heat wheel picks up heat and moisture from incoming air and gives it to outgoing stale air. The fresh air is cooled and dehumidified, providing comfort and eliminating the problems associated with a home being tightly built. It's like living in a climate where a gentle breeze is always blowing. The temperature never gets above 78 degrees and the air is dry. Meanwhile, the heat recovery ventilation is saving 80% of the air conditioning or heating energy needed for ventilation. It uses less electricity than it takes to light a 150-watt light bulb, but it really makes a difference in creating a clean, comfortable environment. In order to further ensure indoor air quality, the Energy Smart Home also uses a Honeywell electronic air cleaner. It's an important part of the home environment system. The air cleaner works in conjunction with the heating and cooling system. The unit is connected to the ductwork. Air is drawn through the intake grills, continuously being filtered and circulated back into the home. This Honeywell electronic air cleaner removes up to 95% of pollutants and irritating particles like pollen, mildew spores, smoke, pet dander, viruses, and dust. The result is a cleaner, healthier home environment. For allergy sufferers, it can make life a lot more pleasant. With an electronic air cleaner, furnishings and draperies will stay cleaner longer. But there's also another benefit. An air cleaner will help your heating and cooling equipment maintain its original efficiency. Cleaner air can reduce operating costs 10 to 25% over the life of the system. This means you save money. So far, we've shown how an energy smart home is well ventilated and practically pollution-free. But now, we're going to take a look at another important part of the home environment system, temperature control. That's the job of a Honeywell programmable thermostat and a Honeywell Chronotherm zoned air distribution system. Both of them enable the heating and cooling system to work more efficiently. This Chronotherm Thermostat is easy to use and gives precise temperature controls. It allows you to program exactly when you want your home heated or cooled and at what temperatures. For instance, during the summer, no one likes to come home to a hot, stuffy house. But with a Chronotherm Thermostat, you can avoid this problem. This is how. While you're away, a Chronotherm Thermostat sets the temperature at a level that saves energy, yet prevents the house from becoming hot and stuffy. Now, before you get home, it's programmed to adjust the thermostat so that it's cool and comfortable when you arrive. It's a smart way of conserving energy, and it's convenient because all you do is program the thermostat for the comfort you want. Then walk away and let it do the work for you. This energy smart home has two of these thermostats, one upstairs and one downstairs. A partner to these programmable thermostats is a Honeywell Chronotherm zoned air distribution system. This system divides the home into two different zones or areas. The Chronotherm controls heating and cooling in each zone. In fact, each zone can be controlled independently of each other. It can even control the temperature of separate rooms. For example, you can keep the downstairs at a comfortable 72 degrees while maintaining 65 degrees for the bedrooms upstairs. That's two zones at once. This system is capable of operating multiple zones simultaneously. Zoning allows you to heat or cool only those areas that need it, not the whole house. This way you save money while maintaining comfort levels. The Energy Smart Home uses all of these features, and it achieves two major objectives: controlling the indoor climate and ensuring your home environment is a healthy one.
The water-saving low-flush fixtures by American standard help protect our natural resources. High-quality performance and sleek modern designs from American standard help make this home unquestionably a home for the 21st century.
The attractive exterior of the Energy Smart Home is a stucco finish called monocouche, introduced in the United States by Parex Incorporated. Monocouche is an intricately colored, crack-resistant, waterproof stucco, which can be applied in one day. It can then be trowel finished in a variety of textures. We selected monocouche not only because it gives the home a very attractive look, but it's more durable and easier to apply than conventional stucco. It's taken several months to complete this home, but careful design, quality materials, and attention to detail have paid off. The Energy Smart Home's tight construction makes it amazingly quiet inside. There are no drafts, and the temperature is comfortable and even throughout the rooms. Let's take a last look at some of the finishing touches. All the electrical fixtures are the type that conserve electricity and have a longer life. The kitchen was equipped by Sears contract seals with Kenmore white-on-white energy-efficient appliances. Some of the features include refreshment center access to the refrigerator, a Genair downdraft cooktop with energy-saving elements, and a dishwasher, oven, and microwave that are all programmable. This is